hence. How often do we say hence? All right. Show that omega is V over 4R. Sorry, I can't do that. Okay, let's see. Okay, so think about this, right? They've just said L is equal to 4/3 mr squared omega. Then they've also said L is mr v. You just figured this out over 3, right? Yeah. This is your answer. I just revealed the answer. That's what you should have gotten in the very first part. Okay, could you set this equal to this and solve for omega? Set this equal to this, the right side of both of these, right? Solve for omega. Good job. All right, and then part 4 says determine the energy lost during the collision, right? So before the collision, we had more energy, right? Because it's probably an inelastic collision when it gets caught by that thing, right? So before we had 1/2 that mass, which is m over 3, right, times the velocity squared, right, in terms of m and v, right, squared. So there's our energy before, right? Afterwards, it's rotational kinetic energy. Remember that rotational kinetic energy is 1/2 I omega squared, right? Now, omega is this. I, didn't you figure out it was 4/3 mr squared? Didn't you figure that out? I think you did. I think you figured out that it was 1/2, that it was 4/3 mr squared, right? Okay, so plug this into there. Plug this into here. Things are going to cancel like crazy when you do that, okay? And then the difference in energy is going to be this thing minus this thing, okay? This thing minus this thing. Plug it all in, cancel that stuff, right? Okay? That's going to be this minus this, and you'll end up with something that's got mv squared and then some coefficient in front of it divided by some number, okay? I'll give you that clue.